Hi everyone, today I'm going to go over the solution for the legal problem, best time to buy and sell stock. So first, let's read the question. So we're given an array of prices where each element, prices I, is the price of a given stock on the ith day. And we want to maximize our profit by choosing a single day to buy our stock and choosing a different day in the future to sell the stock. And we want to return the maximum profit we can achieve from this. And if we can't achieve any profit, we simply return 0. So let's look at a few examples. In example 1, the price array is 7, 1, 5, 3, 6, 4. And so if you notice, right, our output should be 5 because the most profit we can make is when we buy on day 2 when the price is 1 and sell on day 5 when the price is 6. So 6 minus 1 equals to 5. And notice that we're not allowed to buy on day 2 and sell on day 1. Like we can't go back in time. And in example 2, the price array is 7, 6, 4, 3, 1. And the output is 0 because each day the stock price lowers. So we can't make any positive profit on this. And the constraints are that the prices array has at least one element, and this is like the range for each element's value. So let me go over two possible solutions for this. The first one is not so great, the second one is a lot better. So let me go to the first solution. So here, this first solution has a time complexity of n squared. So we're going to use a double for loop, or I guess a loop. And in the outer loop, we're going to be going over each element. In the inner loop, we're going to be going over all the elements whose index is after the element we're currently on, and we're gonna basically take the differences between that element and the current element, and we're gonna be keeping track of the biggest difference. So so go over to each element after the current one, and like I said, we also keep track of the biggest difference. And finally, we either return the biggest difference or 0. Sorry, let me just... or 0. Yeah. And let me go over the... let me do this way using a couple of examples. So, in the first example, so EG1. So the prices array is I think it's like 715364. Yeah. 715364. And so yeah, so like let's go step by step, right? So at step 1, in the outer for loop, we look at the first element, which is 7. In the inner for loop, we basically look at all the elements starting from index 1 to the end, and for each of these elements, we're gonna subtract it from the current element we're on, which is 7. So like 1 minus 7, 5 minus 7, 3 minus 7, 6 minus 7, and 4 minus 7. And we're gonna keep track of the biggest difference, which in this case is minus 1 from 6 minus 7. So step 2. In the outer loop, we are looking at a second element now, which is 1. And in the for loop, we're looking at all the elements from the third index to the end, and for each of those elements, we'll subtract it from our current index, our current element, which is 1. So we're going to be doing 5 minus 1, 3 minus 1, 6 minus 1, 4 minus 1. I'm going to be keeping track of the biggest difference. And this biggest difference is going to be tracked sort of globally. So in this case, the biggest difference is 5 from 6 minus 1. Now we go to the third element. So on step 3, we go to the third element, which is 5. And in the inner loop, we're going to be looking at all the elements starting at index 4 and beyond. And we're going to be taking each of those elements and subtracting the current element, which is 5. So 3 minus 5, 6 minus 5, 4 minus 5. Now, 6 minus 5 is 1, but 1 is less than 5, so our biggest difference is still 5. On the fourth step, the outer loop looks at 3, and the inner loop looks at all the elements after the fourth index. So after the third index, and basically takes the difference. And so 6 minus 3 and 4 minus 3. Again, 6 minus 3 is the biggest one out of the two, or the bigger one out of the two, but still less than 5. So our biggest difference is still 5. And at the fifth step, the outer loop looks at looks at 6, and 4 minus 6 is minus 2, which is less than 5. So still the biggest difference is 5. And now we don't have to worry about the last element. So in this case, we will just return 5. Now, let me go over the second example. So, what was that? Let me see. So that's 7, 6, 4, 3, 1. So, prices is 7, 6, 4, 3, 1. And then step 1, in the outer loop, we look at 7. And in the inner loop, we look at elements elements starting from the first index and going beyond. And for each of those elements, we take the difference between that element and the current element. So like 6 minus 7, 4 minus 7, 3 minus 7, 1 minus 7. Now the biggest difference is minus 1 from 6 minus 7. So that's what we have. In step 2, the outer loop, we look at 6. In the inner loop, so like we will look at 4, 3, 1. Again, because 4 minus 6, 3 minus 6, and 1 minus 6 is all less than minus 1, we just keep using minus 1. Step 3, the outer for loop, we look at the third element, which is 4. In the inner for loop, we look at 3 and 1, and we do like 3 minus 4 and 1 minus 4. Again, the biggest difference is still minus 1, so we still use that. And the fourth step, in the outer loop, we look at minus 3. In the inner for loop, we look at this 1. 1 minus 3 is less than minus 1, so we keep it. And because this is a negative number, we return 0 in this case. Yeah, so this is basically the algorithm behind the O of. So this is a O of n squared algorithm. I'm not going to code this up, and if you do try to code this up on LeetCode, you'll get a timeout error. So now I'm going to go show you the better solution. So let me just zoom out and delete everything here. So now let me use let me showcase the O of n solution, which is a better solution. So we're gonna have a couple of variables. The first one is called max profit, and it will be initialized to 0. The second one will be called current profit, and again, it will be initialized to 0. And the last one will be the minimum price, and it will be set to the first element of the prices array. So now, what we're going to do is we're going to loop through the prices array, starting from index 1, so the second element, and going all the way to the end. And for each element we go through, we're going to do one basic check. If the element that we're going through, if it's smaller than min price, or smaller than equal to min price, we just set min price to that, like our current element. However, if our current element is bigger than min price, we're gonna take the difference, and then our current profit will become the max between itself and the difference, and our max profit will be the maximum of itself and current profit. So let me do like a pseudocode. So I'll call this so num. So this is our current element, and if num is less than or equals to min price, you just set min price to it to be equal to num. However, and let me scroll down a bit. 1 second. However, if num is greater than min price, we'll take the difference, which we'll call profit, and this will be num minus min price. And now we're going to do current num is the max between itself and profit. And our max num is the max between itself and current num. And at the end we just return max num. So let me do a couple of examples. So here, let me do example 1 again. So e.g. So the price away, I believe it was 715364. So I'll call it MP is initialized to 0, our current profit CP is 0, and this is max min price. This is the first element of the price away, which is 7. So in step 1, again, step 1 means we start from the second element. Our num is equals to 1. So we do the basic check, right? So num is less than min price. So our min price is updated to 1. And that's basically all we do for that step. Now let's go to step 2. Our num is 5. So 5 is bigger than our min price, right? So our current profit, our profit, I'll call this P, is 5 minus 1, which is 4. Let me just do that. Equals to 5 minus 1, which equals to 4. Our current profit CP is between the maximum of itself and 4. So right now CP is 0, so it will be 4. And our max profit is the max between current profit and itself. So right now max profit is 0 and current profit is 4. So max profit is 4. Let me go to step 3. So our num here equals to 3. So again, let me just do this and say 1, this is 4, and this is 4. So our num is greater than our min price. So our profit, so let me move the boy over a bit. 1 second. So our profit will be 3 minus 1, which is 2. Our CP will be the maximum between itself and 2. And since since 4 is bigger than 2, we keep it as 4. And our max profit, or MP, is the max between itself and CP, and again, it's going to be 4. At step 4, our num is 6. So that means our profit is equals to 5, because 6 minus 1, right? Our min price is 1. So our CP will be updated to 5, since 5 is bigger than 4. And so are our max profit. It will be updated to 5. So again, this is 5, and so is this. Oops. And in the final step, with step 5, our num is 4. The profit is 3, 4 minus 1 is 3. Our current profit is still 5, because 5 is bigger than 3. And the max profit is still 5, because 5 is, because both CP and MP are 5. So we will return 5. Now, let me go over the second example. So let me put EG2 here. Our price, is like, I think 76531. It's something like that. It's all decreasing. So again, I'm gonna initialize our variables. So our max profit is 0. Our current profit is 0. And our minimum price, I just call it min P, is 7, because it's the first element of the process array. So at step 1, our num, I'll call this n, is 6. So our profit, there's no profit. So because num is less than MP, we're gonna because num is less than min price, we're gonna update min price to be equal to num. So our min price is equal to 6. And that's all we're doing. In the second step, our num is equal to 5. And since 5 is less than 6, we're going to update our min price to be 5. In the third step, our num is 3. And since 3 is less than 5, our min price is going to update to 5. Update to 3. Sorry, my bad. It's going to change from 5 to 3. In the fourth step, our num is 1. And because 1 is less than 3, our min price will be updated to 1. And at the end, we will return MP, or max profit, which is 0 basically, because our max profit hasn't changed. So now let me code this up. I'll code up the second method. So like I mentioned, we're gonna need to have some variables. So max profit is set to 0. Current profit, profit is also set to 0. And our min price, we're gonna initialize it to the first element of the price array. And like I said, we're gonna be looping through the prices array starting from index 1, because we already have the first element, right? So we don't need to go through the first element again. So num, or I guess price, is equals to price is I, and if price is less than or equals to min price is set to price. Otherwise, our profit will be price minus min price, and our current profit is the max between profit and itself, like current profit, and our max profit is the max between itself, max, and current profit. And at the end, we return max profit. Let me just make sure I didn't mess up any variables. Prices, price I, price, current profit, max profit. Okay, everything looks right. Let me run this in locally first, or on a single test case first. If it looks right, let me submit this. And yep, you can see this solution is valid. One thing I want to mention is that this algorithm actually has a name. Oh, it's called cadence algorithm. If you wanna like learn more about it, you can like Google it or something. But it's a pretty neat algorithm. That's all for this video. Thanks for watching.